Welcome to lesson 1.1, where we're going to review the basic rules for exponents, the power rules, and what to do with the power rules when we have variables. So start with a bit of a reminder that exponents represent when we have multiple multiplications of a number. So exponents represent multiple, so more than two, or more than one, sorry, multiple multiplications of a number. So pretty straightforward example. If I have 3 to the power of 4, that means I'm going to have 3 multiplied 4 times. So up here, that's our exponent. And here, that is our base. And the whole thing all together, this whole thing all together is what we call the power. So if we look in the table below, it says we've got 2, and remember, squished together means multiply. So right here, when we have, so squished together means multiply. So when we have 2 times 2 times 2 times 2, we could write this. The base is going to be 2 because that's what got multiplied repeatedly. It got down 1, 2, 3, 4 times, so that's going to be the exponent, and we can write that as 2 to the power of 4. For the next one, we have minus 7 3 times. So the base is minus 7. It got repeated 3 times. And I would write that as minus 7 inside brackets. It's really important to have the brackets because the brackets tell you that the minus stays with the 7 every one of those 3 times it gets repeated, and to the power of 3. For the last one here, we've got a minus sign that's sort of just hanging out front. And then we've got a 5. Now it's the 5 that gets repeated twice. So 5 is the base, not minus 5. It gets repeated twice, so the exponent is 2. I would write this one as my minus sign out front. The 5 gets repeated 2 times when we multiply. So this one, no brackets, because the minus sign just stays out front. It's not part of what got repeated. We're going to move on to exponent law 1. And I'm going to write over here in the box that exponent law 1 is when 2 powers have the same base, you add the exponents. 2 powers with same base, and if they're being multiplied, if multiplied, then you're going to add the exponents. So here we've got 2 to the 1 times 2 to the 2. That dot also means multiply, just a reminder. So 2 to the 1 times 2 to the 2. The base is the same. It's both a 2, so I can write this as 2 to the 1 plus 3, which would give me 2 to the 4. Next one, I've got a base of 7. The bases match, and we're timesing them. So we're going to add the exponent. So it's going to be 7 to the exponent, 8 plus 2, or 7 to the 10. So for the next one, you can probably see right away it's going to be a base of 3. You don't have to write out this 3 plus 2. It's totally fine if you want to go directly to 3 to the 5. If you think, though, that you might make a boo-boo and you might times or subtract or do something else with exponents, do that in between step. For D, our bases aren't a number. It's a variable, the variable x, but I can still write this as a base of x. I'm timesing them and the bases match, so it's going to be to the 7 plus 8, so it's going to be x to the 15. For the next one, bases match, add the exponents, so we get y to the 37. Here's the first time we have a negative exponent, but that's okay because the bases match, so it's going to be x to the 10 plus minus 8, which is the same as x to the 10 minus 8, or x to the 2. And if you were confused at all about what I did there with the plus minus turning it into a minus, make sure you touch base with me so that I can help you out with that. For the next one, I'm going to pick slightly different color to highlight, because here we're only going to combine the powers that have the same base. So here, when I look at the x's, the ones I've highlighted in yellow, it's going to be x to the 5 plus 7 times, because this is all still being multiplied, and then my y's match, so it's going to be to the 2 plus 4. So I'll get x to the 12 times y to the 6. And h is going to be similar to g in that we have different bases here. My first base, here I've got a 2. I'm just going to make this bigger because I want to write some other stuff on it. I've got a 2 and I've got a 2 to the 7. This 2 all on its own is really 2 to the exponent 1. So it's like a 2 with a ghosty 1. Because it's 2 only one time, so it's a power of 1. And then I've got a squared and a9. And remember, squished together is multiplied, so all these are just being multiplied together. So if I deal with the base 2 first, or what's in green, it'll be 2 to the 1 plus 7 times, now I'm going to do the base a, so it's going to be a to the 2 plus 9. And when I add the exponents, I get 2 to the 8 times a to the 11, and we can just leave it like that. A last 2 to do. Going to need 3 colors here, so I've got base 3, then I've got base B, and then base of y as well. So I would have 3 to the 2 plus 9 times b to the 3 plus 7 times y to the 7 plus 8, or 3 to the 11 times b to the 10 times y to the 15. And you could write those all squished together if you want. Totally legit other way would be 3 to the 11, b to the 10, y to the 15. Either way works. Okay. J is going to have something new here. Here, we've got the y's, and they match. But then out front, we have, I'm going to pick, I'll use that green here. I've got these two numbers, and they do not match. But that's okay, because I have a number out front times another number out front. I can just multiply those two numbers. So it'd be the same as minus 4 times 7. That's going to be out front. And then I'm going to be times by y to the 9 plus 4, which would be the same as minus 28 y to the 13. So that was exponent law 1 and the multiplication of powers. Exponent law 2 is the division of powers. So if we are dividing, when dividing two powers that have matching bases, where the bases match. For multiplying, we added the exponents. For dividing, we're going to subtract them. So when dividing two powers where the bases match, you subtract the exponents. So let's practice this a little bit. For 2a, the bases match. So it's going to be 5 to the 10 minus 8 because we're dividing, or 5 squared. This one, the bases match again. So it's going to be, and we're dividing. So 2 to the 7 minus 2 is 2 to the 5. This one here, bases match. So it's base 3 to the exponent 6 minus 3 because we're dividing. So 3 to the 3. Here's our first one with a variable, but the bases match. They're both x's. So it's x to the 15 minus 5 because we're dividing, or x to the 10. For this next one, it combines a little bit of dividing and timesing, or multiplying. So the bases all match. So it's going to be y to the 18 to start off. Divide by y12, so minus 12 times by y to the 4. So we're going to add 4. So we get y to the 6 plus 4, which gives y to the 10. For f, the bases match, and we're dividing, so we're going to subtract the exponents. But we got to be careful because here we've got a negative. So it's going to be a to the 8 minus 7. That's going to be the same as a to the 8 plus 7, which would give a to the 15. And again, if you don't quite remember why minus turns into a plus, make sure you reach out and let me know. G, we're going to be combining what we learned from the first two laws. So I've got timesing on the top or in the numerator of this fraction, and then that answer will get divided by 5 to the 4. So this is, but all the bases match. So I could write 5 to the 6 plus 21 over 5 to the 4. So that'd be 5 to the 27. And that's the same as divided by 5 to the 4, which would be the same as 5 to the 27 minus 4. So 5 to the 23. That's one way. But you might see that we can do 5 to the 6 plus 21 minus 4 all at once. And if it's all just timesing and dividing, you can totally do it that way. And that would get you to the exact same place, because 6 plus 21 is 27. Oh, my pen stopped working. Are you serious? Please no. Okay. I'm going to stop the video and I'll have to continue later. Okay, my iPad's pen is charged, so hopefully I can keep going. Finishing this one, we're going to add the exponent. 6 and 21 is 27 minus 4 would give us 5 to the 23. So either way you do this problem, you're going to get the same answer. For this next one, we have two different bases. We have base 2, and then we also have base x. So we're going to deal with each one, each base on its own. So this would be the same as 2 to the base 8 minus 6, because there was division, times x to the base 7 minus 4. We're subtracting because it was dividing. So we end up with 2 to the 2 times x to the 3. For question I, we have a squared. They're all a's. So I'm going to do this one all just one big sentence. So these top two, I'm going to, because they're being multiplied, I'm going to add the exponent. So it's a to the 2 plus minus 5. And then I'm subtracting this exponent, so minus 7, because it was dividing. We added the minus 5 because it was timesing, subtracted because it was dividing. So plus minus turns into a minus, so 2 to the minus 5 minus 7. So that's a to the minus 3 minus 7 equals a to the minus 10. 3 more to go with dividing. We have all the same base. So again, I'm going to write it as one big sentence. 3 to the minus 2 plus 17, because those bases were being multiplied. Then with the dividing, that's going to come into a subtraction of the exponent. Minus 2 plus 17 gives plus 15, minus 3, so I get 3 to the 12. For k, we have 3 different bases that match up. So we're going to have to deal with each one separately. Also, if you look here, this 6 on the bottom, there's no exponent, but I hope you remember now that it's really a ghosty exponent 1, because there's one of those 6's. So that's 6 to the exponent of 7 minus 1 times y to the exponent of 8 minus 3 times z, make sure it doesn't look like a 2, to the exponent of 6 minus 10, which gives us 6 to the 6 times y to the 5. I'm not writing the dot because squish together means multiply, times z to the minus 4. And that's it for k. L, all the same base. So here I'm going to, where I've got timesing up top and timesing down below, I'm going to deal with that first and then I'll subtract them. So that's x, and I'm going to write it underneath just so that I have a little bit more space. That's going to give me up top x to the 101 plus 405. And then down low, we have x to the 200 plus 300. So up top, I get x to the 505 over x to the 500. And now the bases match, and we're dividing, so we subtract the exponents. So that's 505 minus 500, and our final answer on this one is just x to the 5. Exponent law 3. Exponent law 3 is power of a power. And that means we take a power and then we raise it to another exponent. So when we have the power of a power, so when you have a power raised to an exponent, we multiply the exponents. So for 3a, we have the power 2 to the 3, and it's squared. If we were going to do this old school and write it out long form, it'd be 2 to the 3 times 2 to the 3, which would mean it'd be 2 to the 3 plus 3, which would give us 2 to the 6. But this rule is the same when multiple addition is actually what multiplying is. So we could write it just with these multiplyings in here. So we could write it as, here's a different way, 2 to the 3 times 2 is 2 to the 6. So it's just a little bit faster. We take those exponents and we multiply them. So same with this one here. We've got 3 to the 5 to the 2. So using our new rule, that's going to give us 3 to the 5 times 2, which is the same as 3 to the 10. For part C, even though it's a fraction, we're still going to do the same thing. It's going to be 1/4 to the raised to the exponent of 2 times 3. So that's going to be 1/4 to the 6. And we can leave it like that. I'll show you how to simplify that later, but we don't need to worry about it now. For the next question, D, I'm going to move this just front and center. We're going to have to follow BEDMAS. So we're actually going to have to deal with these exponents first and multiplying the exponents together. So we leave that 4 to the minus 7 out front. And then that's going to be 4 to the 3 times 4, because it's a power of powers, so we multiply them. So that's 4 to the minus 7 times 4 to the 12. Because we're multiplying and the bases match, we're going to add the exponents. So that's 4 to the 5, and that's our final answer. E, pretty straightforward. Yeah, it's got a variable for a base, but we can deal with that. That's just going to be a to the 4 times 7, which is a to the 28. For F, all base Z, we're going to deal with this power of power first. So that's going to give us Z to the minus 8 times Z to the 6 times 3. So Z to the minus 8 times 6 times 3 is 18. We're multiplying and the bases match, so it's Z to the minus 8 plus 18 equals Z to the 10. G, we've got double power of powers, and then we got to divide. So we're going to power of powers those two, and then we'll divide. So that's going to be y to the 7 times 3 divided by y to the 3 times 2, So we get y to the 21 divided by y to the 6. Bases match and we're dividing, so we subtract the exponents, and we end up with y to the 5. For H, it combos all three rules that we've done so far. So first, we're going to have to deal with the power of powers, that part. Then we're going to have timesing, which is in the numerator, and then we'll deal with the dividing. So we have x to the 3 times x to the 7 times 4, and then this whole thing is going to be divided by x to the 17. So that's the same as x to the 3 times x to the 28 divided by x to the 17. So that's x to the 3 plus 28 minus 17, which is x to the 31 minus 17, which is x to the 14. Exponent law 4. Exponent law 4, even though adding and subtracting are easier in just regular integer stuff, when it comes to exponents, adding and subtracting even when the bases match kind of sucks because we can't do anything. We have to figure out each term on its own. So in this one, if we were to put it in our calculator, 2 to the 2 is 2 times 2, which is 4. And then we would add 2 times 2 times 2, which is 8. So we would get 12. So following order of operations, we know the answer is 12. For the second one, again, we're going to have to figure out each term on its own and then subtract it. So minus 3 to the 4, if you were to punch that in your calculator, minus 3 times minus 3 times minus 3 times minus 3, or use the exponent button, which is the hat button on most calculators. It looks like the thing on a keyboard above the number 6. We would get 81, because a minus 4 times would give us a positive, minus, and 3 to the 3 is 27. And when we subtract 81 minus 27, our answer is 54. Now the common mistake, I'm going to show it with this example here. The common mistake of this one is like, oh hey, the bases match, I'm going to add the exponents. But 2 squared plus 2 to the 3rd does not equal 2 to the 5. So you can't add the exponents when you're adding the bases. You can only add the exponents or subtract the exponents when you're multiplying or dividing the bases. So addition, exponent law 4 with addition or subtraction of powers is you must calculate each term separately before you add or subtract them. You add or subtract them. So for 4a, with that rule, that means I got to figure out what 8 to 3 is. So if I use my calculator, 8 to the 3 is 5, 12. And then I have to add 8 and then subtract 8 squared, which is 64. So we're just doing bed mass. We're doing the exponents first. And then with the calculator, 512 plus 8 minus 64 gives me 456. Question B has multiplying, and then there's a minus 5 to the 3. So I can use exponent law 1 to write this as 5 to the 2 to the exponent 2 plus 4, and then I'm going to subtract 5 to the 3. But because it's separated by that subtract, I got to figure out each thing on its own. So that's 5 to the 6 minus 5 to the 3. 5 to the 6 is a very big number, 15625. And then 5 to the 3 is 125. And if we subtract those two numbers, we get 15500, 15,500. So this is tying in all the stuff we did in the review with order of operations, the bed mass. I'm just going to write that out again, bed mass, now with what we've learned about exponents. So in this one, let's look and see all the separate terms. So I have one term here, and then inside the bracket, I have another term here, and then a third term here. So I'm going to figure out each one of those things using my rules that we've learned to figure out what this answer is. So out front, in that highlighted blue thing, I'm going to have 2 times 3 squared is 9, plus 2 to the 5 is 32. Oh, I could use the rule. Let's use the rule here. The bases match and I'm timesing, so I can add the exponents. 5 plus 2 minus 5 times 27. So out front, I've got 2 times 9, which is 18, plus, I've got 2 to the 7 minus, and then 5 times 27 is 135. I got to figure out what 2 to the 7 is. I think it's 128. Yeah, 128 minus 135. And now I have to do the bracket. So I have to figure out what that is. 18 minus 135 is minus 7. So it's 18 plus minus 7, which is the same as 18 minus 7, which is 11. Excited. Inside the brackets, figuring out each term, then I dealt with the bracket, exponents, and the addition and subtraction. For question D has, we're going to have, oh, one sec, the iPad is not enjoying this, so let me go back in. One term out front. Inside the bracket, I have another term. And then this is its own term on its own because it's separated by a minus. And then at the end, we're going to plus that as well. So that first green term, the bases match. So it's 5 to the minus 2 plus 6, which is 5 to the 4. And now inside the bracket, the bases match and I'm subtracting. So it's 7 minus 4 minus 3 plus 9. So that's 3 to the 3 minus 3 plus 9. 5 to the 4 is 625 minus 27 minus 3 plus 9. So I got to calculate that bracket before I do anything else. So it's 625 minus 24. So that's 601 plus 9. So that gives us 610. Hey, 610, robotics, yay. And that's it for using all for the first 4 of the exponent laws. This practice classwork, I'm going to talk my way through, but you probably have enough to do all the homework now. I'm just going to go through. No, actually, I'm going to leave this for us to do in class together. Thanks for watching. Make sure to ask in class or by email if you have any questions.